Hi everyone. We are doing lesson 8 and this is Mr. Chang. Now we are looking at the table of content first. We just want to have a overview or like a big picture of what we are doing, what we are learning. We're learning about relation and functions. So that's the topic of this unit. And then it's paved the way for the coming two chapters, which we focus on a particular function. It's called linear relation, linear function. Now, so what we learn in this unit is basically all the basic concept and units and terminology for learning functions and relations, and we'll learn many functions in grade 11 and grade 12. So, learning all the terminology here will help you in the future. Sometimes in math we don't pay attention to the terminologies, but if you get it right now, understand it, and then in the future it will make it much easier. And what we have learned now will assume you have know it, you know what is the domain and range, like you know what's x-intercept, y-intercept, you know what is a relation, you know what's a function, right? So which or just all this concept, what's input, output, what's independent variable, dependent variables, what are the different ways of represent function, and also how to use a graphic calculator. Okay, so in future courses you will use it as well, but like learning the basic now, you pretty much learn all the how to deal with the graphs, how to find independent point of the graphs. You basically have learned it. All right, moving on. The last few lesson 8 and 9, today we're doing lesson 8, is called function notation. And then we'll solve some problems and then interpreting graphs. So that's the entire chapter. So let's go to our lesson 8. Lesson 8, we're going to learn something called a function notation, a way to represent function. We saw in lesson 7 what is a function. Okay, so for every input, there is only exactly just one output, then that is a function. So we're going to now learn how to represent functions. So it's like learning some ways, right? Learning some symbol to write functions. Now, last lesson we saw a way to show input and output, which is like this. A function is defined, so put a colon here, x mapped to y, and input mapped to output. Given a certain input, what is the output? So they give you an example here. Consider the following function. Any input x will map into 2x plus 3. So if the input is 5, what is the output? Plug in a 5 into x, and then 2 times 5 plus 3 is 13. So this is a general representation for a particular value. You can write 5 will map to 13 under this function. So this is input and output. Now we have another name. The output can also call the image of 5 is 13. So the output can also be called the image. We can also say the value of the function is 13 when x is 5. So when the input is 5, y is 13, the output is 13, the image is 13, the value of the function is 13. So the function refer to the y value. The function will map x into y. So when we say function, we refer to the y value. Let's look at the function notation. So instead of using the mapping notation, in the future courses, the function notation is more common. So we'll write f of x. Okay, so it's read f of x. The function f represent a relationship between two things which map the input x into its value of x, f of x. All right. So x is x, f of x is y. Okay, x is x, f of x. When you see that, is the output of x, is the y. Okay, so y is f of x. Okay, x is x, but y is f of x. So make it very clear. So in the above example, the function f can be defined by this formula. So instead of using this mapping notation, we'll just write f of x is 2x plus 3. So whatever x you put in here, that's the input, the f of x, the output, it will be 2x plus 3. We call this way of representation a function notation. Okay, so let's look at the following. This is the mapping notation. After this lesson, after this course, you won't see it anymore. From now on, everything will be in function notation. And then the only difference between the function notation and the equation of the graph of the same function is just instead of having f of x, you just write y. Okay, so x and y emphasize you have two different variables, x and y. Here, the function notation, you still have two things, x and f of x. Remember, f of x is y. F of x is y. So if you compare this, you can say it's the same thing. But the f of x, this notation, represent or like emphasize it is a function of x. It is related to x. Emphasize the relationship. Here, emphasize the two separate quantity. So I have an analogy. You can have two persons, x and y. They're related, okay, but they're not married yet. So two persons related. But now, once they marry, okay, now they change the last name. I'm now called f of x. So when you have this, it's to emphasize, it's the same thing. It's to emphasize the relationship, f of x. Here, emphasize two person, the two quantity. Okay, so it can call f at x or f of x. So I'll usually just say f of x. So f of x provide a formula for f. It represents the value. So when you say f of x together represent y, when you see x alone represent x. I mentioned it many times, but people tend to confuse or mix it up. All right, so note, in function notation, f of x does not mean f times x. This bracket doesn't mean, this bracket is not actually operation in the bracket. There's nothing to do with bad maths. It's a notation. It's a way to write it. So you always write f of x together as one unit. And then f is the name. Okay? So usually it's just called f. You can write g of x, h of x. They just represent the name of the function. It's called g and h. But then whenever you write something like this is a function notation representing a function. Let's look at some example. So given this function, evaluate the following. Here you are giving two functions. One is called f of x, one is called g of x. And then we evaluate, okay? So whatever input of x you put in, the output will be this, which is your y. Alright, so what's f of 3? This means when x is 3, what is y equal to? Alright? So when x is 3, what's y equal to? F of 3 represent y. So you plug in 3 in place of x. I always put a bracket in case it is a negative, then you will square the whole thing, not just square the 3. Okay, so you put a bracket to replace x with the value. So 9 plus 5 is 14. So you can write f of 3 is 14. So what's g of 1? Replace x with a 1. The answer is 3. F of negative 2, replace x by... In this example, the brackets is important. If you don't put a bracket, it will read negative 2 square. Well, you square the 2 first and then put a negative. That's wrong. You need to square the whole thing, which make it positive 4. Okay, so very important. So when we replace the x, we always put a bracket. Okay, so same here, 4 minus negative 2. Like without the bracket, 4 negative 2, it reads wrong. Okay, here we go. Okay, what does this mean? Well, which means replace f of x with a 0 and then minus g of x. Now you minus the entire expression, so you can put a bracket around it like this. Okay, it make no difference in this question, but it will make a difference. Like because like if there's another number you distribute, or you need to evaluate that first before you minus it, so it will make a difference. Okay, so it's equal to 1. So that's the example. Okay, next, if I have the following, determine f of negative 3. This means when x is -3, what is y? Well, y is f of x, so you write what is this? Okay, this means the same thing. So you replace x with a 3. All right. Well, I'm in a playground, so you hear some kids yelling. Okay, 5 times -27. -2 times -3, that's +6. All right. The brackets is important. You cube -3. If you don't write bracket, it reads very weird, like 5 minus 3, like it's all wrong. So put the brackets there, and then you evaluate this. This is 135 plus 6. So the answer is 141. Okay. Now let's read B. The value of f. What's value of f? Which means f of x, right? When x is 2, now we know the value of x is no longer x is 2, so which means f of 2. What's f of 2 equal to? So we replace it with a 2. When x appear in two places, you replace both of them with the same value. All right, 5 times 8 is 40, minus 4 is 36. Okay, 2 to the power 3 is 8. The image of 7 under f. Okay, this is the input, which is x. X is 7. The image is the output, is the function of x, is the value of x. So it's f of 7. All right, you put a 7 there, and then you just find out the answer. And then you just find out the answer. All right. The expression for f of a. Oh, okay, an expression. So you're not looking for a number, not looking for a value, not looking for an answer. You're just looking for an expression. What does f of a mean? Which means now your x value is a. You just replace x with a, right? Remember in other example, you replace x with the value. Now you replace x with a, so you do the same thing. Okay, you can put a bracket there, you don't need to put the brackets there. And that's the answer. F of a is this. You just replace x with a. So that's a function notation. The expression for f of 2x. Okay, what does that mean? Replace x with whatever in the bracket. If they are value, you replace it with a value. If it's an expression, you replace it with an expression. So I'll just replace x with 2x. Don't forget the bracket. Replace x with 2x. It's like that. Now you simplify. 2x cubed is ax cubed. 2 times 2 is 4x. So your final answer is 40x cubed minus 4x. All right, so this is what you do. All right, next example. Now we have a function called p of x. All right, instead of f, well, you can use any letter you want. So it's p of x. Simplify expression for px minus 3. All right, so what does it mean? Well, you just do what it says. Okay, you replace x with x minus 3. So x minus 3. You replace every occurrence of x, okay, here, with x minus 3. So I'll write x minus 3 minus x, x minus 3 minus 1. All right, they were x, now they replace this with x minus 3. And now let's simplify it. Okay, you need to follow Batmus, so let's do the square here. So when you square, all right, so that's the answer. All right, here you need to expand. You can do it once you can carry the negative with you. All right, negative 6x, right? Negative 6 times x. Negative 6 times 3 plus 18. All right, this distribute. So let me write the final answer. 4x squared. Okay, 4 times negative 6x minus 24x. Minus 24x minus 6x, that's minus 30x. Plus 36. Plus 36 plus 18 minus 1. All right, so plus 53. Okay, so that's the end for example 3. There's a few more example. I'll make another video just for just a very short video just to capture the last few example. See you in next video.